everyone, my name is Rahel Rahimzad.
Hello, my name is Faris Al-Jofi.
My name is Rolando Sorio, and we are the NAE group for Engineering Better Medicine. Welcome back from commercial break. If you've just joined us, we're about to do the last segment of the day. 3 university students have developed code which could change the lives of diabetics forever. We will now take you to the University of Houston, where we have sent a reporter to interview these students.
Hello, yes, it is as you said. We are at the University of Houston, joined by one of our guests, Rahel. And so, from my understanding, your group has developed a code?
Yes, that's correct. The purpose of this code is to help the diabetes monitoring their BMI, the sodium ions, potassium ions, chloride ions, through the concentration from the sweat, and also as well as we can control the glucose level from the sweat sample test.
Alright, so why did you guys begin this project?
We had this as a class assignment for an engineering course. We had to create a code that would help engineering better medicine. We hope to create something that would help diabetics control their glucose and sodium levels. There is a lot of emerging technology that uses sweat. Sweat contains both sodium and glucose. Out of the two, sodium can be directly measured from sweat. Glucose can be indirectly measured based on the fact that glucose levels in the blood and sweat are correlated. Therefore, spikes in sugar glucose levels would translate to spikes in blood glucose levels.
Hello, darkness, my old friend. I've come to talk with
Here's that
you.
we're having some slight technical difficulties. We'll be right back after this thing gets fixed, actually. I don't know when we're going to come back. So, why do you think that the issues that Faris mentioned are important to diabetics? Okay, so type 2 diabetics don't always check their glucose levels as often as they should. This is mostly due in part that they have to prick their fingers on a daily basis, sometimes even more than once a day. And the pain associated with this process of monitoring glucose is most likely going to cause them stress, so they're not going to want to do it. So as a result, people might not actually be getting the appropriate doses or treatment that they need. For diabetics, there's many complications that come with high blood glucose levels, such as blindness, nerve degeneration, lower limb amputation, and in fact, in 2012, 2.2 million deaths were caused by high blood glucose, and in 2015, 1.6 million deaths were directly caused by diabetes. So diabetes in itself increases the risk of heart disease and strokes, and this risk is further increased with patients that do not monitor their glucose levels. So it is to my understanding that your code also takes ion levels into account. Could you explain why?
Yeah, sodium levels are also something that need to be checked, even though most people don't really put 2 and 2 together. Extra sodium in the bloodstream pulls water into the blood vessels, with more blood flowing through blood vessels. Blood pressure increases as shown in the Framingham heart study. High blood pressure is one of the major risk factors when it comes to developing heart disease. The number 1 cause of death in the United States, high potassium levels are a sign of kidney failure, and high chlorine levels might signify poor sugar level control.
Alright, so what goals did you guys set for your code?
Yes, we are hoping that this will put a patient health at their fingerprint. After the technology is fully developed, the sensor, which will most likely be in the form of a bracelet or watch, will have Bluetooth technology, which will allow interaction with the user's cell phones. So it would probably be analyzed every few minutes and show trends over time to users in order for them to realize what they have been doing wrong diet wise through trial and error, rather than make inferences about their health from one measurement at a random time of the day.
Could you please take us through how your code works?
Yes, this code is developed for two types of the method, ions and the glucose level from the sweat, and also it's worked for to put the individual input or to as a groups. When you start the programs, you run the programs, there is a user inputs menu selection from you wants to run the programs as an individual person, or no, you wants to is work as a group. If you want to work as a groups, you need a range. It's out of this range. Inputs it was out of this range. They ask you is give the warning, and as the user inputs the data, the value in range. If it is not okay, they ask again. If yes is correct, this give you output the results, and then ask to type of the method. Which type of the method do you want to check the glucose level for the groups? And if it is yes as a groups, the number of the user is so important, so we have to put the number of the group we want to check, and the program goes through the for loops and ask about the age, the weight, the gender, the height, and after that they calculate the code calculation, the BMI depends on the user input. If it was just as an individual person user input, so this directly goes through the user input for the individual person. After that, when you calculation the BMI, we need to check all the values is in the range and data validations, and if it's out of the range or out of these validations, so give the warning and ask again the user to input the value and or replace the value. So after we correct the user input the in range value, again ask about what type of the testing we are interested, the user interested is ion or glucose. If it was a glucose, so we put the glucose as a level in the range. If it was out of the range, again ask the user to input the range and mention what is the range of the glucose so the code is working on it. So if not is the ions, so they ask about the input the range of the ions sodium, potassium, and chloride. So again, if it was out of the range, again give the warning and ask the user input the in range. And when the user input in the range, they give us the status of the person as a diabetes or not diabetes, and show the plot as a group. In this group, the first person of this group, what is the status? What is the second person? What is the status? Is it diabetes or non-diabetes? And if the again after this part, there is the menu. They ask again if your user wants to run again. If not, this is the end of the program and the user comes out from the program. If yes, again back and start and asking the type of the method and also the individual type or the group type. This is all the programs we are doing for this checking the diabetes or not diabetes patient from this test.
Alright, I'm very sorry. The last time I tried this, it didn't work. So let's just try to run this. Let's say that there's an individual of the age of 36. They weigh 248 pounds. They are 5 feet tall. And they are male. So we're going to want to get their ion concentration. This would be calculated through a machine. So let's say that their sodium concentrations are going to be at 250. Their potassium concentrations are going to be at 170. And their chloride concentration is going to be at 500. So we're going to display this data right now. As you can see, this person has a very high BMI, 48, and this chart comes up and appears. It is very easy to visualize, for a person at least, that there is a problem with their concentration of ions. Their sodium seems to be okay, but their potassium concentrations seem to be very high, which, if this keeps on happening, it could show a very, very, very big problem with maybe their kidneys. Maybe they're starting to fail. Maybe there's some other disease involved. For chlorine, this could signify that a person has very, very poor control over their glucose concentrations. It could mean dehydration. And so if someone has very high concentrations of sodium, they could end up developing high blood pressure, which is a very big concern, since blood pressure is one of the major risk factors for heart disease, which is the #1 killer in the United States. So let's run our code right now. So let's say we want to get individual data. The individual is probably going to be 24 years old. They're going to weigh 346 pounds. They're going to be 6 feet tall, and they're going to be male. So now you're going to get their concentration for glucose. You're going to get their information before breakfast, and let's say their glucose concentration is going to be at 7. So as you can see right here, it displays that the glucose concentrations are too high, which is a very, if this keeps on going on, it could mean that the person is diabetic. And that's pretty much it. Alright, so in the future we hope that future engineers use our code as a blueprint in order to help keep track of diseases with biomarkers located in sweat or other biofluids for that matter, to monitor patient health throughout spread out time intervals, to let the patient see previous results, and to make this the way that things are done, rather than single doctor's visit results or single measurements taken at any random time of the day. This will in turn help prioritize and personalize. This will in turn help personalize a patient's medicine. As for limitations, this code is based on developing technologies. If sweat sensors are not accurate, our code will not provide accurate results. There is also the fact that there won't be a possibility of getting blood glucose levels from sweat glucose levels with the current research that there is. This could change in the upcoming years if there are new methods of sweat sample extraction. Thank you.